So addition polymers are where we join together lots of alkene molecules. We're now going to have a look at condensation polymers. Okay, so condensation polymerization is where we join together monomers and we usually lose a small molecule. It's either water or HCl, and this one therefore requires two different functional groups. Okay, so addition polymers only require alkenes. Condensation polymers require two different functional groups. And we're now going to focus, in this video, we're just going to focus on one of those condensation polymers, and that is polyesters. Okay, you should have heard of polyesters in terms of materials made on an industrial scale. Polyesters are essentially ones where we have ester linkages. Okay, and we're now going to have a look at examples of that. Now, there are essentially two ways of making polyesters, and they differ in the monomers that we can use, or the types of monomers that we can use. The first type is where we use one monomer, and that monomer has two different functional groups within it. I'm just going to use FG for functional groups. Okay, so within one molecule, within one monomer, we're going to have two functional groups. If we're making an ester bond, the two functional groups that we should be looking at are carboxylic acid and an alcohol. Okay, so what we can have is just one monomer. I'm just going to do an example here. One monomer with a carboxylic acid on one end and an alcohol on the other end, like so. Okay, you don't need to know specific examples. I'm just doing an example here to show you how this polyester is formed. Within this molecule, we have both the functional groups that we need. Okay, so that means we just need this monomer, or we need lots of this monomer. So essentially, we just need loads of these drawn out. Obviously, I'm not going to draw out all of them. I'm just going to draw out two. And we can now see how that ester bond is formed between these monomers to form the polyester. Now, when we form an ester using a carboxylic acid and alcohol, we lose a water molecule, and essentially the water molecule that we're losing is this H2O over here, and therefore forming a bond between this carbon and this oxygen here. Okay, so what I'm going to do is I'm going to draw out the polymer that this forms. And remember, when we draw out the polymer, we have to show these kind of extended bonds that are coming out of the square brackets. So if I just start drawing this. So this is that ester bond that's forming. And on the other end, remember, we're losing that that OH to the water molecule when it joins to the next monomer. So this is where the polymer ends in terms of us drawing it. Okay, so as you can see, in terms of what's happened, we formed this ester bond here. So I'm just going to kind of show you the ester bond. So you need to be able to identify the ester bond within a polyester. And as you can see, in terms of this molecule repeating itself, if I essentially just pick up this and put it over here, you should be able to see that an ester bond would form between this part and that part there. Okay, so make sure you don't have an oxygen at either end. You should only have oxygen at one end and a carbonyl at the other end when drawing your your polyester. Okay, hopefully you can see that I've actually drawn two repeat units here. Okay, so if I were to just by the side, I'm going to draw what one repeat unit would look like, so you can see the difference. Okay, this over here is one repeat unit. Okay, so essentially this over here is just two lots of those next to each other. Okay, and remember, don't forget, we are also producing that water molecule in this process as well. All right, so that is one way that we can form a polyester. Okay, where we just use one monomer that has both the functional groups in it. Or what we can do is use two different monomers, each with one type of functional group in it. So, second method. Okay, so what I mean by that is obviously we need to have an alcohol, we need to have a carboxylic acid. We are now going to use two different types of monomers. In one, we're going to have one type of functional group. So in this one, I'm just having my alcohols. You need to have two alcohols, that's to be a diol. So this one here is just ethan 1,2-diol. So that's one monomer. The other monomer therefore needs to have your carboxylic acids in them. So I'm just going to go for this dicarboxylic acid, like so. Okay, so essentially in this one we just have kind of alternating the diol, dicarboxylic acid, diol, dicarboxylic acid, and so on. Okay, and again we need to lose a water molecule, and this is the H2O that you lose over here. Just between these two monomers here. So if I now draw out one repeat unit for this polymer, okay, so I'm going into the ester bond, and again make sure you don't have oxygens at either end. You only have oxygen at one end and a carbonyl at the other end, so that when you pick this up and repeat it, it then forms the ester bond on the other side. Okay, as you can see, I've formed my ester bond here, like that. Okay, and I released a water molecule in this process over here. And hopefully you can see that this over here is one repeat unit. Okay, this whole thing, because we've used two different types of monomers, this is one repeat unit here. Okay, right, another thing to point out, I've said, or in this we've used the example of esters being formed by carboxylic acids and alcohols. Remember, we can also form esters using acyl chlorides and alcohols. Okay, so any kind of example here where I've used carboxylic acid, I could have just used an acyl chloride. Okay, so I'm just going to show you that. Rather than using this dicarboxylic acid, I could have used, I'll just rub this out and do it again. I could have used this compound here, which is just a diacyl chloride. Okay, so now rather than using a water molecule, I actually would have lost HCl, okay, hydrogen chloride. And when I draw out the repeat unit, I will actually make the exact same polymer. Okay, so it still has an ester linkage in it, like so. Okay, but now this time I've released a hydrogen chloride molecule. So just to point out, anywhere where I've used a carboxylic acid, if I use the equivalent acyl chloride to that, I still would get the exact same polymer. Okay, it's just that the small molecule that's released, that changes. Okay, if I'm using an acyl chloride, I will release hydrogen chloride. If I've used a carboxylic acid, I release water.